Good morning, class. This is the lecture for September 15th, AP CSP. We are going to be having a fun day in Unit 1, Lesson 9. Our agenda is the warm-up and in lossless compression. We have assignments to complete the Unit 1 L9 activity guide. That's going to go along with what we're doing today. Students will be able to compare data compression algorithms to determine which is best in a particular context. Okay, so we're going to be looking at data compression. We're going to be in Unit 9. If you want to open up your code.org, we'll go to Unit 1, Lesson 9, Lossless Compression. Okay. This list represents several common abbreviations used in text messages. What other abbreviations could you add to this list? LOL, TY, see you soon. What other things do you know in terms of abbreviations? You can stop the video. We'll give a minute. Okay, let's hear what you've got. Great ideas. Why might we use abbreviations when sending messages? What are the advantages? Why did people who started texting create TTFN? Yes, they were tired of wearing out their thumbs, typing out all the letters, so they started to shorten things to make it simpler. The only problem is the other person needed to understand what that acronym was. Okay, today we are going to try and shrink things. We are doing text compression. Here's a poem. Pitter patter, listen to the rain. Pitter patter on the window pane. Right? We are going to be looking at text compression, and what we're going to be doing in Unit 1, Lesson 9, is we are going to be compressing text. We're going to be using the text compression widget, and what it is going to do for us is it is going to replace whatever words we ask it to, and we are going to make a library out of those. See how this is actually the same thing as the full poem. What they've done is represent pieces of it. So pitter patter, right? Same thing down here. That is star. Ooh, look at this. They've really broken this down. This is crazy. So star actually doesn't even equal text. It equals snowman, light, snowman, light. So what is snowman? Snowman is PI and umbrella. Umbrella is TTER, so that is the pitter. And then we have pat umbrella for patter. So pitter patter is represented in that snowman little light. So pitter patter is what star is. Listen to, sun is the. We've replaced the text with symbols. How is this message on the left the same as the first message, or the message on the right the same as the message on the left? What actually gets sent to my friend? When I send a message, I'm sending this poem to my friend, I'm writing it out. Pitter patter, listen to the rain, pitter patter on the window pane. And I'm sending it to my friend, and what happens? They just get the text. But this is the interim. This is how the computer manages to create a smaller message to send that is more compact. All right, we're going to go in and we're going to look at our text compression widget and how it works. Okay, So navigate to code.org, lesson 9. We're going to go in level 1 and try to compress the text. We'll do this for about 3 minutes, let's say. So you can stop the video. We can start up again. How did that go? Let's see. Here we go. How are you doing in your compression? What were you able to reduce the size of this file? Okay. Our next section is going to be to make a note of your compression rating. Okay. This is for, so wake me up when it's all over, when I'm wiser and I'm older. All this time I was finding myself and I didn't know. That's what I believe the stars are. Didn't know I was lost. So that's that. You can see it was compressed by 25%. Okay. What strategies are you using to compress your sample text? Which one seems most successful? Okay, we'll pick back up. Typically, it is things like repetition of words. Those phrases that are repeating are easy to pick out. Really parsing it out like that PI and TTER equals umbrella equals snowman, that was a little more than I was ready to do when I first looked at this. I can get the repeated words. All right, now we're going to watch this video. When it's done, we can start again. Okay, how about that? All right, we're going to continue to try and compress this text using some strategies that were just discussed. All right, so this is, so wake me up when it's all over, when I'm wiser, when I'm old. We're going to try this one in the widget, see how we do. Okay, you can stop the video for, let's say, 4 minutes. Okay, how did that work? So if you click the drop-down menu, you can explore other text to compress. Be looking for text that you could predict will be easy to compress and text that you predict will be difficult. I can see right away over here, one of these texts seems to be very easy to compress, okay? But what is it that makes a piece of text difficult to compress? That idea that everything seems to be different. All right, step 1, decide which neighbor, with your neighbor, choose an easy message and a difficult message that you both attempt together, okay? So step 2 is pair compressing. Use one computer, work together to compress the easy message as much as you can. Using the other computer, work together to compress the difficult message as much as you can, okay? So one computer will have your easy message, one will have your difficult message. You're both gonna work to compress the easy and the difficult as much as possible, okay? Let's see what happens, okay? Once you've done that, let's, we can, I'm sorry, it's a little late. I can give you, let's say 3 minutes to try this out. Do 4. Okay, let's pick up again for the wrap up. So how did that work? Were you able to compress the difficult one, much less than you were the easy one? Ideally, that should be the case. So in the wrap up here, what made some messages easier to compress than others? Let's think about that. Then also, what made some messages more difficult to compress than others? What was it you learned in that last piece of the exercise? Typically, it's the idea that easier is multiple sections that are repeated, long sections that are repeated, multiple words repeated. The more difficult is that it's all seemingly random or original, that you're not getting those big repetitions that you're looking for. That's where you have to start choosing pieces of words or something so that you could find a more universal thing to represent. Okay, lossless compression is a process for reducing the number of bits needed to represent something without losing any information. This process is reversible. What we have been doing is lossless compression. We can totally recreate the exact message word for word with our system for compression. Okay, this is lossless compression. Tomorrow, we will be working on lossy compression, compression that actually loses data as part of the process. This, as you see the top and the bottom, it translates into something, but the sender and receiver are receiving the exact same message. No information is being lost in lossless compression. And that's it for today.